Today we will start with complex integration using Cauchy's integral theorem and integral formula. In this video I will discuss about definite integral only. In this lecture series I will teach you how to solve different types of integration using contour integral. ये लेक्चर सीरीज पे हम एक एक टाइप पकड़ेंगे और उसको कैसे सॉल्व करना है वो मेथड स्टेप बाय स्टेप एग्जाम्पल के साथ सीखेंगे। ठीक है, बिफोर वी स्टार्ट करने से पहले जो कुछ ज़रूरी बेसिक प्रॉपर्टी है डेफिनिट इंटीग्रल का वो हम देख लेते हैं। डेफिनिट और जो थ्योरी है वो देख लेते हैं। सो फर्स्ट, होल मॉड इज लेस देन separately mod. Remember this property, we will use it later. Now come to Cauchy's integral theorem. So first I am writing this theorem. First of all, if a function fz is analytic and its derivative f dash z continuous at all point inside and on a closed curve C. So बेसिकली हम आर्गन डायग्राम पे वी कंसीडर ए क्लोज कर्व C. This is a closed curve C, and let us assume if fz is some function. This is analytic inside this closed curve C and on this line, curve line, and f dash z, its first derivative, is continuous at all point inside and on this closed curve. Then we can say closed line integration along C fz dz equals to 0. This is Cauchy's integral theorem. Now this is a simply connected region. What would happen if we take a multiply connected region? Now we draw a multiply connected region. This is the outer circle C1, and into this outer circle C1 there is another circle C2, and fz is analytic in the region between these two circles C1 and C2. Let us call this region R, rename this as R. Then we came to extension of Cauchy's theorem to multiply connected region. So Cauchy's theorem says that theorem to multiply connected region says that if fz is analytic in the region R between two simple closed curves C1 and C2, then we can say closed line integral C1 along fz dz equals to C2 z dz. This will be equal. तो हम कोई भी एक बाउंड्री के अलॉन्ग एफ जेड डी जेड का इंटीग्रल कर सकते हैं, वो इक्वल होगा. सो इफ एफ जेड इज एनालिटिक इन द रीजियन आर, दिस इज बिटवीन two simple closed curves C1 and C2 in this region. It is called a multiply connected region. So in this case we can integrate through any one of this boundary of this region R. Now we will discuss Cauchy's integral formula. So Cauchy's integral theorem says that if fz is analytic within and on a closed curve C, that is the condition of the first one. Let us draw a closed curve C, and the here fz is analytic within this closed curve and in this curve C, and if fz is analytic within and on a on this closed curve C, and if a may be here or here, any point inside closed curve C. Let us assume A is this point. Value of this fz in this point A, that is fa will be this 1 by 2 pi I closed curve integration fz by z minus a dz. Remember that a is not the middle point or center of this curve. A is any point inside this curve. If we want to obtain first derivative of function fz in this point A, then the theory will be f dash A equals to 1 by 2 pi I closed curve integration along C fz by z minus A whole square dz. Similarly, now if we want to obtain nth order derivative of fz at this point A, then the theorem will be f nth order derivative. It is dn dan of fz at point z equals to A. This will be nth factorial by 2 pi I closed curve integration along C fz by z minus A whole to the power n plus 1 dz. This is the required theory. So here we will not prove any theory. हम यहाँ पे कोई थ्योरी प्रूफ नहीं करेंगे. आप अगर प्रूफ देखना चाहते हो तो इस वीडियो के कमेंट सेक्शन में कमेंट कर सकते हो. नाउ थ्योरी पार्ट अब तक जितना हमें चाहिए वो कंप्लीट हो चुका है. अब आते हैं हमारे फर्स्ट टाइप का इंटीग्रेशन पे. पहला टाइप है 0 to 2 पाई फंक्शन ऑफ cos थीटा और साइन थीटा, cos थीटा साइन थीटा डी थीटा, इस टाइप के. हेयर वी विल नोटिस दैट एफ ऑफ cos थीटा साइन थीटा जो होगा वो असल में एक कांस्टेंट बाई फाई ऑफ साइन थीटा cos theta. Now to convert sin z cos z into z, we consider a circle of unit radius with center at origin as contour. Now this is C such that mod z is equals to 1. Its center is at origin and its radius is 1. So we can write z equals to e to the power I theta. So dz will be I e to the power iota theta d theta, and d theta equals to dz by I e to the power I theta, and we know let that z equals to e to the power I theta, so dz by iota z. Now as the limit is from 0 to 2 pi, this is the full circle, so the integration is along the closed curve C, which is mod z equals to 1. This is the step 1. Now come to step 2. From Euler's identity we know that we can write cos theta as e to the power I theta plus e to the power minus iota theta by 2, and we assume that z is e to the power iota theta, so we can write it 1/2 into z plus 1 by z, and similarly we can write sin theta as e to the power iota theta minus e to the power minus iota theta by 2 iota. This is 1/2 iota into z minus 1/z. Now we get cos theta sin theta and d theta. Now put all these things in the function f of cos theta sin theta, so this convert to function of z. This integrand is converted into a function of z. Then apply Cauchy's residue theorem to evaluate the integral. Here the contour is mod z is equals to 1 phi z dz. Now evaluate this integral using Cauchy's integral formula. Now we take an example. इसको हमें सॉल्व करना है. तो अकॉर्डिंग टू द मेथड आई डिस्कस्ड प्रीवियसली, we take a closed contour C, which is a unit circle whose center is on the 0 0 and whose radius is 1. So mod z is 1, C such that mod z is 1 and z is e to the power I theta. So dz is I e to the power I theta d theta, that is Iz d theta, and dz by Iz is d theta, and cos theta is this thing we see previously. Now put all these things in this integration. So this integration become closed curve C, because 0 to 2 pi, this is the closed curve C. 0 to 2 pi 1 upon 5 plus 3 into 1 by 2 z plus 1 by z, and d theta is dz by Iz. Now simplify this equation. Ten plus 3z plus 3 by z by 2 dz by Iz. So this 2 goes to here, and we multiply this z by this. Now we have to find singularities of this function. To find this, we have to put denominator equals to 0. This iota is here. Now if we factorize this will become 3z plus 1 into z plus 3 dz. Now we have to find singularity of this function. Singularity of this function. So singularity is simply that we put the denominator equals to 0. That is 3z plus 1 into z plus 3 equals to 0. From here we get 3z equals to minus 1 and z is minus 1 by 3, and from here z plus 3 equals to 0 and z equals to minus 3. So we get two singularities. One is in minus 1 by 3 and one is minus 3. Let us locate this singularity. This is a unit circle, so this is minus 1 and this point is plus 1, and minus 1 by 3 is inside this circle. So here somewhere is minus 1 by 3 and minus 3 is somewhere here, minus 3. So the only minus 1 by 3 singularity is inside this circle C. Now we previously read our theorem, that is Cauchy's integral theorem. Cauchy's integral theorem says that if A is any point inside this C and fz is analytic, here fz is analytic, here if we assume this is a whole function phi z, we can see that this phi z have singularity at z equals to a. So we use this formula. Here. So to using this formula, we have to convert this integral look like this. तो वो फार्मूला हमें अप्लाई करने के लिए इस इंटीग्रल को उस टाइप की इंटीग्रल में लाना पड़ेगा. तो हमें क्या करना है? If we take 3 common from here, then it's become like this. Now if we write iota 3 into z plus 3 by z plus 1 by 3 dz, and if we assume fz is 2 by iota 3 into z plus 3, then we see that this function is analytic everywhere inside this circle C and on this circle C. Here no singularity, because this function has singularity in -3. We can clearly see that. But inside this circle and on this circle there is no singularity. So this is fine. And z plus 1 by 3, this can be z minus 1 by 3. So minus 1 by 3. Now, as we know in Cauchy's integral theorem, that if a, where a is any point inside this circle C, is 1 upon 2 pi I fz by z minus a dz. So here a is minus 1 by 3 and fz is this. So we have to find fa, that is f of minus 1 by 3. So 2 upon iota 3 minus 1 by 3 plus 3. This is 2 upon iota 3 into 9 minus 1 by 3. These three cancel out. 9 minus 1 is 8 and 2 4. That is 1 upon 4i. Now here, so we can write this as, this is this. So this 2 pi I we can move here. So we can write this as C fz by z minus 1 by 3 dz. So this is equal to, the theory is fa equal to 1 upon 2 pi I close contour integral fz by z minus a dz. So we can say close contour integral fz by z minus a dz is 2 pi I into fa. So here we can write 2 pi I into fa. Here a is minus 1 upon 3, and we already evaluate this. F of minus 1 upon 3 is 1 upon 4i. So 2 pi I into 1 upon 4i. I cancel. This is pi by 2. So the integration 0 to 2 pi 1 upon 5 plus 3 cos theta d theta is pi by 2. And this is the answer. Now here are some examples. You can try these integrals at home. ये दो इंटीग्रल भी सेम टाइप का है, आप ये घर पे ट्राई कर सकते हो. अगर नहीं हुआ तो मुझे कमेंट पर लिख कर बताना.